Okay, so this next one is a Thevenin equivalent, and it also uses source transformations again. So practice that a little bit. So it says to use source transformations and resistor simplification to find the Thevenin equivalent and Norton equivalent circuits to the left of nodes A, B in the figure below, then determine I. So we're looking for the Thevenin equivalent of this part of the circuit. So the Thevenin equivalent allows you to reduce the entire circuit to a current source and resistor, or voltage source and resistor, and then you don't have to worry about how it works. So what you're actually going to be building is this part over here that has the I. And you don't really care about everything else. You just want the simplification of it. And so that's what we're going to do here. So we are going to simplify this. So first we see that we have a 5 amp current source and a 2 ohm resistor in parallel. We can change that to a voltage source and a resistor in series. So V equals IR. The current source is 5, the resistor is 2, so that makes it 10. The resistor stays the same. Now we also have a current source and a resistor on top. The resistor stays the same. The current source becomes a voltage source of 10 times 3, which is 30. And then that's 12 ohms. Now notice that everything we have over here is in series, so we can combine them. If we look at our voltage sources, if we travel along the wire, we're going minus, plus, minus, plus. That means that they're going to add together. If they were opposite, if it was minus, plus, plus, minus, then they would subtract. But they will add together, so that will give us a voltage source of 40. And our resistors will add together to be 12. And the part we're looking for is over here. Now, V Thevenin is the same as V open circuit. So that's going to be the voltage across these terminals. Now I have a 40 volt voltage source and 2 resistors, so I can just use voltage division. Now what's nice about this is that these resistors are identical, and so I know it's going to be 20 volts. But if I wanted to use the formula, I would say 40 times this resistance over the sum of the 2 resistances, which would give me 20. Now, our Thevenin I get R Thevenin by shorting all voltage sources, making all voltage sources short and all current sources open. So I'll short that voltage source. And I want to see what is the resistance from the point of view of A and B. And from the point of view of A and B, these two 12 ohm resistors are in parallel. And when you have resistors in parallel, Req is half of the resistance, so it's 6 ohms. So R Thevenin equals 6 ohms. So we had V Thevenin equaled 20, R Thevenin equaled 6. If we wanted to do it as a Norton, so that means it would look like this. So this would be 6, and this would be 20. That would be our Thevenin equivalent circuit. If we wanted our Norton equivalent circuit, use V equals IR, I equals V over R equals 20 over 6. .3. And the Norton equivalent circuit would look like this. And we are supposed to use one of those to determine I. So if we go back and look at our original picture, we can now say that I is going through a 4 ohm resistor to the right of A and B. So we can just use this simplified circuit. And V equals IR, V is 20, I times 10, or I equals 2 amps.